After exporting our image from Inkscape, we can move on to creating plots. First, let's take a look at the data that we'll be plotting. As you can see, we have a data file named fieldminmax.dat, and it contains several columns of information. We will be using Matplotlib to create a graph showing how these two columns, we take any two of them, changes with time. To get started, let's set up a Python script to plot the data. Here is a quick Python script to do the job. First, we import the required libraries to plot. And then next, we create a figure. It's important to note that the size of the plot should respect the dimensions of the document. Since we know the text width of the document for which we are preparing the plot is about 6 inches, let's make our plot 5 by 4 inches. This will make sure that the plot will fit within the document. Now let's import the data to plot. We'll specify the directories and file name and read the data. That includes time and two different columns, two different properties. Then we'll specify the line types and the symbol, and finally plot them. With our plot complete, we can now add labels, add title and any other necessary details to make it look professional. And when we are happy with it, we can save the file in a format that's suitable for inclusion in our document or presentation. Now let me quickly show you the result of running this script. So I've included 3 different formats to save the same plot: PDF, SVG, and PNG. If you do not want to edit and just want to attach this to a document, then it's better if you choose a PDF format. SVG is also a vector format, but if you want to edit it once you create the plot, either in Inkscape or PowerPoint, it's better to use SVG. PNG is a rasterized image format, and it's just for preview in my case at least. So let me run this script and I'll open the PNG. Now if you look at the plot, the aspect ratio does not look nice. The entire document was about 6 inches and we set our file size to 5 by 4 inches. Since we have 2 plots, let's make this a 6 and this a 3, so that each of those plots would have same aspect ratio, 1 aspect ratio. And let me rerun this. Now you can see how our plot looks. As you can see, there are all sorts of parameters that we can change, such as the font size here, the tick marks, line style, and many more. And some journals would have specific requirements for the size and style of the plots. They would specify what the size of the font should be in title, a different font size for the axis labels, and for these labels on tick marks and such things. And changing each of these parameters in every Python script can be tedious. So to make this process easier, we can include a default parameter setup in our Python script. This can be done by cloning the Pyblish repository from GitHub. Let me show you the repository. So this is the repository that I'm talking about. And if you include this file in your Python script, the default parameters are already set here. So if you go through the default parameter setup script, this one, you will see how the defaults are specified and how they can be changed according to your needs. Maybe you can change the font size depending on your own specific needs, or you can change the plot style. You can make it a monochrome, or any style you like. You can specify the line width, size of your markers, and many more. You can go through this document and see what things you could change. For very specific changes, I suggest that you import the default script into your Python script and then add the specific changes you need in the plot script, rather than changing the default script every time you need some change. So this way you can easily customize your plots without having to change the defaults for every script. Now let's look at how to include this default parameters setup script from GitHub and set the default parameters for our plots. First, we'll clone the repository by running the clone command. To get the name of the GitHub repo, go to the homepage of the repo and copy. After that, do clone and paste the link and hit enter. I have already cloned the repo, which is this one. After cloning the repo, we can add the directory to our Python scripts path and import the script that sets the default parameters. Then we can rerun our script to see the difference in the plots. So to include the file that I just showed, the publish.py, but which is inside Pyblish Python. So after including this, I can rerun the script. But let me change the name of the files. Let's say this is 2. Save it and run. Let me open the new plot. Now you can see the difference between these two plots. In one case, the LaTeX render engine is used to render the texts, and also the size of the tick labels and the labels on the axis are exactly what we have specified in the default Python script. Next, we'll open the plot in PowerPoint and make a few minor changes. While PowerPoint can be convenient for this, it will eventually produce a rasterized image. If you want to maintain the vector quality of the image, it's better to use Inkscape instead to edit your SVG file. Okay, I'm in PowerPoint right now, and I'll import the SVG file here. So this is the SVG file just imported. Now we can do the minor changes that we want here. To add LaTeX equations in PowerPoint, we will need to install IguanaTex extension, which I have already done. You can find the installation instructions and the download link in the description of this video. In PowerPoint, we can highlight certain regions of plot that's interesting. We can add some equations using IguanaTex or do some minor changes and then export this to the format that we want, and then import this in the Overleaf document. Let me quickly do that. Once we are done with the minor changes in PowerPoint, we can go ahead and export this. First, I'll group this and then export this as a image, as a picture. And save it as PNG. Once we save it, we are good to go, and we can go ahead and attach this. Let's go ahead and do that. This is where we left off in our Overleaf document. I'll go ahead and upload those two plots that we made. So these two are the plots that we made and uploaded. Now I will attach this to the document. I'm just copying this frog image and I'll change the name of the files. So one was from PowerPoint and another is from Inkscape. So I will go ahead and attach our images to this document and remove the frog. While making the image from PowerPoint, the size of the image was not specified, although we specified the size of the image in Python. The final size of the image while exporting from PowerPoint could change. So let's specify the maximum width of that image to be the same as the text width, which was around 6 inches. So we're good with that. And for the second image, which was created from Inkscape, which is, oh, you cannot preview it, which is this one. This is already in actual size, so we do not want to change the width of this image while attaching. So for that, I will remove the resizing thing. And once I recompile, okay, this is the result that we got. So you can see the size of the fonts are preserved, the size of the image is preserved, and in this case as well, we know that when we made this image, it was about 3 inches, which should be around half of the text width, which is, and this is how you make your own plots and include them in your Overleaf document. And that's it. Here I showed my workflow on how to create plots and schematics for Overleaf documents. This is my personal workflow, but of course you can customize it to fit your own needs and preferences. I hope you found this tutorial helpful. Thanks for watching.